now. Okay, so it's a little just the basics of how we laser cut a model. Now, we will talk about it again when we have more knowledge of Revit. But what if we're working fundamentally in Rhino? How would that work? I'm going to try to laser cut these two models, which are very similar. But I'm going to do a cut to this one. It's a little bit different. So I'm going to do a plane, and I'm going to do a rotation here. I'm going to get rid of ortho and try to cut this thing just like that. Trim. Oops. Trim out. History, delete, and cap. So this has another close cap. Well, I did this so the typical the more difficult things is actually to laser cut the angle shapes of a roof, for example, in a house or something like that. So let's do both of these guys. How we could laser cut in, and take consider that this in the future could help you do a laser cutting model or laser cutting project of a model that comes from Revit, and we will talk about that when we get to Revit. So basically, export the Revit model as a DWG. You can open it here or in AutoCAD, and if you were to take it into Rhino, you can just work out your way to create your drawings that you can send to laser cutting. Okay, so let me purge here all the layers. It's clean. Okay, so you have a solid, maybe it's many solids, but basically the whole idea is making sure that you can actually create line drawings out of every single surface. So you need a line drawing from here and another one from there. So you can do it in many ways. I want to just talk about one of them. Is explode your solids. Okay, and basically you're going to have a bunch of surfaces. Let's say 1, 2, maybe 1,000. I don't know. Okay. What we need to do is extract, and there's several tools that we've been looking at issues of how do we create from curved surfaces, but there's a bunch of tools in Rhino that allows you to get curves from surfaces. It's the opposite. So instead of generating surfaces from curves, is generate curves from surfaces, and that would be a curve from object. Okay, you can do the duplicate face border or duplicate border of any of these faces. So for example, if I click here duplicate border, automatically creates that little rectangle. Okay, so we could do that, and that's a closed one. So if I actually go back, Control Z, and I have exploded this, I can select all of these guys and do this, bring them out, maybe a different layer called laser cut lines, and make sure that right click, you take them there, change object layer, and you can turn it off and on. You can even change the color if it pleases you. Okay, now there are many closed curves there. There's this one, this one, etc., etc. Makes sense. We can do the same here. Explode, extract or duplicate borders. I don't know if that worked or no. Let me see. No. So explode, duplicate borders. There they are. And say laser cut lines 2. So there are 2 set of lines. Oops. Right click, change your layers. Save that. Okay, we have a bunch of closed polylines, which is exactly what we need. Closed polylines that allows you to laser cut. For those that haven't laser cut because of the pandemic or whatever it is, laser cut is basically a digital fabrication strategy that allows you to send polylines to a machine that throws a laser exactly following that particular line, no? So the big question is, well, I have a digital model. How do I get a set of lines, and where do I put them so I can send them to Mr. LaserCAD, no? So I'm not going to be talking about the requirements from the LaserCAD at CAVE or at different universities. I'm just going to say how to produce a bunch of lines that you can LaserCAD. What I do recommend is that, for example, Thomas Jefferson University at CAVE, there's a person that is in charge of the LaserCAD. In this case, is Drake's name, and he's in charge of the fabrication lab. So he, Drake, will inform you about, hey, this is the template you need to use to LaserCAD, and these are the layers that you need to use in order to cut, score, etc., etc. I can talk a little bit about those things, but again, because each LaserCAD is different, you should talk about the exact process with Drake in regards to, hey, how do I talk to this laser cutting, which are very simple, so it's not a big deal. Okay, let me turn off this thing. So let's imagine we're laser cutting this. We basically need every single of those lines, projected into the floor, no? So some of them are very simple because you just, rotate them 90 degrees and you move them on. Other ones are already there. Other ones are pretty much parallel to them. So some of them are very simple. Just rotate 90 degrees with your tools. Other ones are not as simple, and I'm going to move them over here. I mean, they're very simple, but just not as simple on how we actually place them where they should be. Okay, this is simple, 90 degrees. And this is simple, 90 degrees. Why are these not so simple? Well, because if I rotate them 90 degrees, they still are in an angle, no? So that's a tricky one. I could try to rotate these guys slightly, but I'm not going to get it precisely, no? So how do we actually rotate these guys so they're aligned to the C-plane? I mean, there are easy ways to do it. I'm just going to teach rotation 3D in this case. You can do it in other ways. You can just go, for example, to the front view or to the top view, for example. Where's the top? Yeah. And do a couple of rotations. You can do rotate and then, rotate from here to there, 90 degrees. So I'm pressing ortho now, shift, enter from here to there, 90 degrees. So I'm rotating them, rotate from here to there, 90 degrees. Okay, so basically some of those now are very simple. I just need to rotate them 90 degrees here. And they will be in the category of, hey, easy stuff now. Another way is just using the rotate 3D. Rotate 3D allows you to select an element, and basically you can do 3 rotations in an axis, and then you can rotate normally from here. So there's a couple of rotations until it's flat or parallel to the C-plane. Okay, so I can do rotate, for example, from here to there, like that, 90 degrees. Another one is prepare, rotate here, here, there, 90 degrees. And this one you can do from here, from the front view, rotate from here to there, boom, 90 degrees. Okay, so all of them are at different heights, but they're all parallel, and that's what we want to the C-plane. Remember, the C-plane is the grid. So there's a command that's very nice, and it's basically what it does is takes everything down to the C-plane. It's project to C-plane. Okay, if you want to delete which we do want. Oh, every one of them are now in the C-plane. Now it's a work of 2D. And here's the thing, you will be given from Drake or from any laser cutting manager a template. A template is normally like a rectangle or a series of rectangles. Normally it's a couple of them. And normally it has some layers here saying cut, whatever it is. And this is pretty much the size. It marks the size of the laser cutting. You can't do anything bigger than this. I mean, you can just laser cut several times for a bigger project, but in essence, you need to put your stuff inside of that template, and that template will have layers as well. I'll talk about it in a second. You need to bring those in, nicely organized and as close as possible. You don't want to be so close as that. You want to be as close as you can so you don't waste material. There are actually other tools, very nice plugins for Rhino that allows you to do this automatically, like just pressing a button, but we don't have that plugin. So it's not that practice, nevertheless, to organize your drawings, your line drawings in the template manually. You might be able to rotate. Of course, I was just not lucky. I just created a template that was similar size to all of my pieces. Okay, so this is how it looks like a laser cutting project. No, you have a bunch of lines that corresponds with the three-dimensionality of a project, and you will send this to the manager of the laser cutting. And here's the thing: you need just several layers that they will be given to you. And I'm just going to reduce it to 3 ideas. One of them is cut. Other one is cut. Let's say 1 and cut 2, and they will probably have a different name for this, but the concept is the same. And then score. Okay. So cut 1 is the first cut, and you don't have that need right now. But let's imagine that you have an opening here for whatever reason. Maybe there's a window in some of those. If you imagine how the laser goes through the models cutting, imagine starts right there and starts cutting first this piece. Okay, when it comes to the end, this piece gets loose in the bed of the laser cutting. Okay, if it's loose, then the laser cutting, imagine if it comes afterwards to cut the window. That means that it's not going to be precise. It's going to be cutting slightly off from what it has to be. You will do every inner cut. You need to bring them into the cut 1. And again, the colors and the layers, that's depending on the laser cutting manager. But you want to create those openings and cut them first. So the laser comes and cuts this, zoom, 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 and then the big piece. We don't care if that one is loose because it doesn't matter, but we do care that the big one is not loose. Then all of the green guys are going to be in cut 2. And score is very important. Score, what it means is it doesn't go through the material. It won't cut. It will just mark. It's almost like drawing with a laser, you know? And you can use it in many ways. Some people use it as textile. If you do a hatch, for example, for this, that you have many hatches also in Rhino. You place that hatch underscore. I'm going to change the color. That will mean that the laser cutting will be marking this, not going through it, and you can have like a nice texture. Okay, so for that is very important, but most important is for the following. And here's a question for everybody. Well, I'm cutting this. I have all of these pieces. I don't know how to put them together. No, that makes sense. I just messed up the whole thing. So this is in the part of the video you're going to get here. Say, oh, you should have told us before. Well, this is a learning curve. So we need to go and turn on our project. And before we actually do anything, we need to mark these guys with a number or a code. How? Well, you need to place somehow a word or a text here. So how do you do that? Well, you can just assign different ways of marking text. One of them could be as simple as adding like A1 or something like that, and then snap it to a particular place. And it will be wise to create a layer with text code or something in a particular layer. Okay. So you want to keep it where next to the face. Okay, I'm just going to do it like that fast. Every single piece of your project should have a code. So that will be, and you can double click on the text, A2, or you can just number them 1, 2, 3, etc. Okay, so you have a name in each of those shapes, and then what you're going to do is also place that when you do the exploded, and you get the lines, you need to have those codes somewhere here. I'm copying these numbers and place them where they are. Maybe you want them in the corner. I'm gonna go to the top view. And this, yes, this one with all of the codes, not just those two. Are the ones you want to send. Let's see. A1, A2, A1. There. Okay, nice. Make sure they're flattened, of course, because otherwise it won't work. So they have to be there. And score, basically, you want to get the line of that. You can double click and say, I only want the perimeter. So, well, you can score the whole thing as well. That's perfectly fine. Style. Explode. There you go. If you explode them, you can get the line, and those should be in our score layer. Okay. What does that mean? When I'm done and I send it to the machine, I have two things. You need two things, obviously. You need the code in the 3D model with the A1, A2 in every single phase. And then you need the code in the physical model when you send it. And it needs to be a queued score so it doesn't really, destroy your model. You could even put it as a way in the back of the model so it doesn't really show in your model, but you definitely need a type of code in that sense. It could be simpler, like 1, 2, 3, but each of the numerical codes have to be different for each of them, so you know by looking at the 3D model where they go. If it's a complex model, if it's a simple one, you can just literally actually, let it be, no problem, and mount it by eye. But if it's a little complex like this one, you're going to know a bit more where each of those codes are precisely. You will open Rhino, look at the numbers, look at the physical laser cutting result and then put them together accordingly. So that's pretty much. So, okay, so in resumes, again, a process of the 3D model. It might have come from Revit, by the way. You explode the physical nerves, the physical model that you have. You extract the curves. You make sure you add codes in the 3D model. And each of those curves that you extract from the model, you need to rotate them and place them on the C-plane and organize them in a template that you can request from the manager of your laser cutting, whoever that person is at the moment. The manager will give you a template. The template will have at least 3 layers. It might have more. I think there's a score and there's also a dash condition, but basically, essentially, you're going to have a cut 1 and 2, which is first order and second order. And then you're going to have a score option. This will allow you to do whatever you want to do in terms of cutting, scoring, etc., etc. Okay. So this is basically the basics of laser cutting from a model to the template in Rhino. Okay.